Combustion involves a hydrocarbon reacting with oxygen. Inside this tank there's propane. It's a hydrocarbon. It's made of hydrogen and carbon. It's reacting with oxygen in the air and it's producing carbon dioxide and water and a lot of energy, as you can see. I'm going to do another combustion reaction by blowing a combustible material over this flame. That material is cornstarch. Do not try this at home. Cornstarch is very finely ground, so it's going to burn very well, and whenever something is very finely ground like sawdust, carbon, cornstarch, there's a potential for causing a fire. Here we go. Here's the magic show. So color change is a very important indicator that a chemical change has occurred. This beaker's got some water in it, just tap water. I'm going to put some phenolphthalein in, which is an indicator. It's a pH indicator. And the pH of this changes. The pH changes when it's about 8 or 9, so it doesn't change right at neutral. Inside this beaker, I'm going to put a tiny bit of ammonium hydroxide. Such a little bit that you hardly will see it. It's got a very strong smell. Whew, that's really strong. Just the fumes have started changing this already. Inside this beaker, I'm going to put a tiny bit of sulfuric acid, concentrated sulfuric acid. That's why I've got gloves on. But again, such a little bit that you won't hardly see how much I've got. I'm going to pour the water with phenolphthalein into this beaker to show that we've got a basic solution, and then it's going to be neutralized by the acid, and I don't think become neutral, it's going to go slightly acidic because that is a very strong acid. So here's the magic show. So color change is a very important indicator that a chemical change has occurred. And the chemical change that was happening here was a reaction called neutralization, which is actually also a double replacement reaction.